Part 5 discusses in detail how to develop seismic rehabilitation plans using CEBC Appendix Chapter A3. Part 5 includes figures and tables reproduced from the California Existing Building Code 2010 edition, copyright 2010, California Building Standards Commission, Sacramento, California, reproduced with permission, all rights reserved. CEBC Chapter A3 is a prescriptive construction method that uses rules and tables rather than relying on engineering methods to calculate earthquake demand and building capacity. Homeowners and contractors using Chapter A3 should check with the local building department for any modifications or additions required prior to the beginning of work. The application of CEBC Appendix Chapter A3 has been broken into a series of 11 steps, which will be covered one at a time. These steps are also covered in a separate 8.5 by 11 handout. Step 1. Verify IEBC scope limitations are met. Step 2. Draw a plan of house and crawl space. Step 3. Conduct condition survey. Step 4. Determine new foundation requirements, if applicable. Step 5. Identify foundation sill plate anchor spacing. Step 6. Select foundation sill plate anchorage details. Step 7. Verify rim joists, blocking, and connection. Step 8. Identify distribution and amount of bracing. Step 9. Select details of cripple wall bracing. Step 10. Verify ventilation, access, and flood openings. And Step 11. Quality control. Step 1 involves checking to make sure that the dwelling falls within the intended scope of CEBC Appendix Chapter A3 provisions. If answers to these questions are yes, then proceed. If any of the above answers are no, then the dwelling is outside the intended scope of CEBC Appendix Chapter A3 provisions. Consult with a building official, architect, or engineer regarding recommended rehabilitation measures. If answers to these questions are yes, then proceed. If any of the above answers are no, then the dwelling is outside the intended scope of CEBC Appendix Chapter A3 provisions. This list identifies weaknesses that require rehabilitation. In this list, a yes identifies a weakness that must be further evaluated and/or rehabilitated. This list is based on CEBC Section A303. This is a continuation of the same list. In this list, a yes identifies a weakness that must be further evaluated and/or rehabilitated. For item 5, foundation sill plates would be considered inadequately connected if anchor bolts are, on average, spaced more than 6 feet on center. For item 6, cripple walls would be considered inadequately braced if there is no plywood or OSB sheathing, or if plywood or OSB is not properly installed. If the answer is yes to one or more items above, then proceed with rehabilitation of those items. In this photo, foundation sill plates are not bolted to the foundation. Exterior walls are poorly braced with straight sheathing. For this dwelling, an answer of yes should be provided for items 5 and 6. This is a candidate for foundation anchorage and cripple wall bracing. Step 2. It is recommended that a plan be drawn of the dwelling and crawl space. The list identifies information recommended for inclusion on the plan. Check off each item as it is completed. Step 2 continued. Ventilation opening requirements for crawl spaces in new dwellings can be found in the CBC or CRC. It is recommended that adequacy of vent openings be evaluated and possibly improved as part of the cripple wall rehabilitation. Flood opening requirements for crawl spaces in new dwellings constructed in whole or in part in flood hazard areas can be found in CRC Section 324. It is recommended that adequacy of flood openings be evaluated and possibly improved as part of the cripple wall rehabilitation. Step 2. This foundation plan illustrates location of the required and recommended information items. It serves as an ideal basis for choosing bolting and cripple wall bracing locations. A survey of the existing conditions needs to be made in order to determine the scope of work required for installation of the rehabilitation measures. See CEBC Section A304.1.2. A series of yes/no questions are posed for this condition survey. Questions A and B are based on Section A304.1.2. Questions C and D are based on Section A304.2.2. Questions E through J are recommended based on past California rehabilitation experience. Items that are answered yes will impact the extent of rehabilitation work. Survey Item A addresses decay in framing members that are part of the strengthening. This photo shows decay, damage to existing cripple walls. It is necessary to replace decayed or otherwise deteriorating framing members in order for the seismic rehabilitation to perform as intended. Signs of ongoing decay damage should also be brought to the attention of the homeowner so that sources of water can be identified and fixed. Potentially hidden decay in foundation sill plates is an item of interest. ATC 50-1, Chapter 4 discusses the investigation of moisture content and the replacement of decayed sills. Probing of sills for decay damage extensive enough to affect anchor bolt strength is recommended. To be of concern, look for moderate to extensive decay in the immediate vicinity of anchor bolts or other conditions that would significantly affect the ability of the anchor bolts to perform. Step 3, Condition Survey continued. Item B, similar to Item A, affects the framing to which rehabilitation work will be installed. Note also that termite repairs to the cripple wall or foundation can sometimes result in a modified configuration that requires evaluation by an architect or engineer. If unusual conditions are encountered during the condition survey, evaluation by an engineer or architect is encouraged. Item C addresses partial perimeter foundations and requires evaluation by an architect or engineer. When evaluation by an architect or engineer is required, this should be a licensed professional with experience in seismic rehabilitation who can evaluate whether or not the existing condition of the dwelling is adequate for the earthquake loading anticipated by the building code. Step 3, Condition Survey continued. Item D addresses unreinforced masonry foundations, and Item E addresses deteriorated foundations. The concerns raised by these items are very similar and so are discussed in combination. Unreinforced masonry foundations and existing foundations that have been exposed to moisture over a long period of time can have substantially reduced material strength. This is true of both concrete and masonry foundations. Checking with the local building official is recommended to see if there is a history of foundation deterioration problems in your area. For these foundations, one potential concern is inadequate in-plane shear strength. ATC 50-1, Chapter 4 recommends that existing potentially weak concrete footings be tested by striking them with a hammer. Concrete that does not readily break off is considered adequate for carrying the relatively low stresses borne by the cripple walls. Where mortar in unreinforced masonry foundations can be very easily scraped out with a screwdriver, additional evaluation is suggested. Testing methods are available to verify in-plane strength of masonry where adequacy is of concern. Where weak existing foundations are found, another potential concern is whether the foundation will be strong enough to develop required anchor bolt capacities. This figure shows a detailing approach that might be considered for anchor bolts in weak concrete or masonry. A key of concrete is cast around a new bolt. To resist sliding, the bolt will push on the concrete key and the key will push on the larger area of the existing foundation. This will lower stresses and increase the effectiveness of the anchor. This detail has had limited usage in Southern California. Judgment is required in deciding if this detail is adequate or if the foundation is so weak or deteriorated that foundation replacement is needed. Note that expansion bolts are not recommended for installation in weak foundations. Vertical cracks that have approximately uniform width in a concrete foundation are often due to concrete shrinkage, and they are only of possible concern if more than 1/8 inch wide. Vertical cracks of varying dimension and diagonal cracks are often due to differential movement of the foundation, settlement, soil creep, expansive soils, etc. Thin cracks are not of concern, but wider cracks may indicate a soils issue that should be brought to the attention of the owner or of a geotechnical engineer. Significant vertical or horizontal offsets to either side of a foundation crack are one indication that foundation movement might be significant. In that case, evaluation by a geotechnical or soils engineer is recommended. Item F addresses rusted anchor bolts. A few local areas have experienced significant rusting of anchor bolts to the extent that they may not perform as intended. Check with the building department to see if the problem has been experienced in your area. Light rusting of anchor bolts is a common occurrence that is generally not of significance. Significant rusting of anchor bolts can often be identified by applying a torque wrench, hammer blows, twisting with locking pliers, or prying with a crowbar. Where extensive rust is suspected, addition of replacement bolts is recommended. Item G addresses unusual framing conditions. Framing conditions that are not reflected in CEBC Chapter A3 may occur from original construction repairs or alterations. Where typical details do not apply, additional engineering guidance will be required. It is important to identify this condition prior to the start of construction if possible, so the additional cost of engineering guidance can be identified for the homeowner. Item H addresses damaged existing framing and inadequate repairs. These conditions should be brought to the attention of the homeowner. These conditions may also result in framing conditions that are not reflected in CEBC Chapter A3. They may occur from original construction, repairs, or alterations. Where typical details do not apply, additional engineering guidance will be required. It is important to identify this condition prior to the start of construction, if possible, so the additional cost of engineering guidance can be identified for the homeowner. Inadequate ventilation should be identified. Where inadequate ventilation has led to wood decay, it is recommended that ventilation be improved as part of the seismic rehabilitation work. Inadequate site drainage should also be identified. Where inadequate drainage has led to wood decay, it is recommended that drainage be improved. Step 4. Determine when new foundations are required. These photos show dwellings damaged by the 1992 Cape Mendocino earthquake. The dwellings have isolated foundations at each wood post. A new continuous foundation or partial foundation would be required for these dwellings. New foundations are also necessary when partial continuous footings have been evaluated by an architect or engineer and found not to be adequate. Step 1, Weakness 3. Unreinforced masonry foundations have been evaluated by an architect or engineer and found not to be adequate. Step 1, Weakness 4. Otherwise determined to be applicable. This may include deteriorated foundations that are found to be too weak to carry in-plane shear or to anchor to. CEBC provides two details for new foundations where existing foundations are found to be inadequate. Detail A3-1, shown here, is a concrete foundation with a concrete stem wall. Detail A3-2 provides a concrete foundation and masonry stem wall. All details of dimensions and reinforcing are provided. Foundations could also be designed by an architect or engineer. Where foundations are being replaced, a shoring system adequate to provide temporary support for the dwelling will need to be constructed. Step 4. This table provides minimum dimensions for new foundations. See IEBC Figure A3-1. Step 5 addresses size and spacing of anchorage between the wood foundation sill plate and the foundation. Required foundation sill plate anchor spacing is determined per second column of Table A3-A, depending on the number of stories above. This anchorage requirement may be met using a combination of existing and new bolts. In addition to the spacing requirements of Table A3-A, the number of anchor bolts per section of sill needs to meet the requirements of Table A3-B. This illustration shows a plan view of a foundation and foundation sill plate. End and center-to-center distances for anchor bolts are shown. See Chapter A3, Section A304.3.2. It is recommended to show new anchor locations on the retrofit plan. Step 6 addresses selection of foundation sill plate anchorage details. Where sufficient height exists, the simplest anchorage approach is to install anchor bolts using adhesive or expansion anchors. The anchor hole needs to be installed using a rotary hammer, which requires significant height at the cripple wall. For moderate and low wall heights, alternate details are usually used. Steel plate washers are required at each anchor bolt in the foundation sill plate. Sill bolts and bolting plates should always be galvanized because of the damp, underdwelling environment. Steel plate washers, 3 inch by 3 inch by 0.229 inches, are required on new anchor bolts. See figure footnotes. Addition of plate washers on existing bolts is recommended where possible, but not required. Step 6. This photo shows an alternate anchorage connector. Conditions did not allow for installation of anchor bolts. This is an alternate connection from wood dwelling to foundation per Section A304.3.4.1. The spacing of these connectors is to be the same as specified by Table A3-3 for anchor bolts. Step 6. These figures show alternate details for anchorage to the foundation. Step 7 addresses the connection between the floor framing and the cripple wall top plates, where a cripple wall is present, or foundation sill plate, where cripple walls are not present. Where floor joists are perpendicular to the foundation, this involves two considerations. First, the presence of rim joists or blocking within the floor depth, and second, the fastening from the rim joist or blocking to the top plates or foundation sill plate. Where floor joists are perpendicular to the foundation, you need 1. In a 1 or 2 story dwelling, you must have a continuous rim joist or full depth blocking in alternate bays. 2. In a 3-story building, you must have a continuous rim joist or full depth blocking in all bays. This photo shows cripple walls, joists perpendicular to wall, and existing blocking between the joists. Close examination can determine whether or not there is an existing rim joist or existing blocking at the perimeter. In circumstances where rim joist or blocking is required but not existing, provide wood structural panel blocking in accordance with figure A3-9. In 2- and 3-story buildings where floor joists are perpendicular to the foundation, the connection of the rim joist or blocking to the foundation sill plate or cripple wall top plate must be verified to be a minimum of 8 penny toenails at 6 inches for rim joist, or 3 8-penny nails per block, or retrofit with framing clip in accordance with figure A3-8A. It is often difficult to locate existing nails, if they are present, because some or all of them may have been driven from the exterior face of the wall. As a result, it is common for new framing clips to be provided. Where floor joists are perpendicular to the foundation, the photo shows clips installed from top plates to blocking as an alternate to toenails. The angle clips shown are equivalent to the generic clip shown in the figure. In 2- and 3-story buildings where floor joists are perpendicular to the foundation, the connection of the rim joist or blocking is applicable whether framing is supported on a cripple wall for concrete or masonry stem wall. Figure A3-8C shows connection of rim joists or blocking to the foundation sill plate. At the sides of the dwelling where floor joists are parallel to the foundation, additional items need to be considered. The end joist or rim joist must be located over the foundation, in contact with the foundation sill plate or cripple wall top plate, and continuous except for access and ventilation openings. This photo shows an existing continuous rim joist parallel to the foundation sitting on a foundation sill plate. Standard floor joist blocking appears at the right-hand side. Where the required end joist is not adequately installed, provide wood structural panel blocking in accordance with Figure A3-9. In addition, in 2- and 3-story buildings where floor joists are parallel to the foundation, the connection of the end joist to the foundation sill plate or cripple wall top plate must be A. Verified to be a minimum of 8 penny toenails at 6 inches, or B. Rehabilitate with framing clip in accordance with Figure A3-8B. Again, it is common to have to provide framing clips because existing toenails cannot be verified. Step 8. The amount of required cripple wall bracing is determined using CEBC Table A3-A, columns 3 and 4. Step 8. In addition to meeting the required percent of wall length per Table A3-A, the requirements of Table A3-10 for distribution and amount of bracing must be met. Where these requirements cannot be met, design by an engineer or architect is required. In addition, the following are required for bracing. 1. Must have a width not less than 2 times the sheathing height. 2. Install bracing as close as possible to the intended location where obstructions occur. When the requirements for bracing cannot be met, an engineered design will be required. Step 9 addresses detailing of cripple wall bracing. Figure A3-5 shows cripple wall sheathing applied to the exterior face of the cripple wall. Exterior wall finish materials would have to be removed to allow this placement and reinstalled afterwards. Figure A3-6 shows cripple wall sheathing placed on the interior face of the cripple wall. This is the most common placement. The detail also shows a condition in which the foundation sill plate is wider than the studs. As a result, plywood sheathing installed on the interior face of the studs stops on top of the foundation sill plate. In this case, the bottom edge of the plywood is nailed to plywood blocking between the studs. Nailing of the blocking is specified. An alternate approach cuts the foundation sill plate flush with the face of the studs. Figure A3-7 shows additional details of cripple wall bracing that must be used with either detail A3-5 or A3-6. Alternate details for vertical joint at abutting plywood panels. 1. Install the 1/8 inch gap between abutting panels to allow for expansion with moisture change. 2. 2 2x studs or 3x studs are alternatives. Vent holes are required to mitigate moisture buildup in stud cavities. Rodent screens on vent holes are suggested. 15 32nd inch plywood or OSB sheathing is a practical thickness to use for cripple wall bracing. Thicker sheathing does not hurt to use, but it does not significantly improve performance either. Nail bending is predominant behavior. Sheathing with exterior exposure rating is highly recommended. 15 32nd inch plywood or OSB sheathing is a practical thickness to use for cripple wall bracing. Thicker sheathing does not hurt to use, but it does not significantly improve performance either. Nail bending is predominant behavior. Sheathing with exterior exposure rating is highly recommended. Sheathing nailing must be A. 8 penny common nails with a minimum 1 1/2 inch penetration into framing. B. At 4 inches on center at sheathing edges. C. At 12 inches on center at other framing members. D. Driven flush with sheathing surface. E. Do not break sheathing face with the nails. If the nail breaks the face, add another nail halfway between existing nails and hand drive flush. This photo provides a good opportunity to review the full scope of retrofit from anchor bolts up. Here we can see the foundation sill with anchor bolts, the sheathing, replace decayed members, and flat clips to new plywood blocking. Step 10. Verify ventilation access, and flood openings. Cripple wall bracing and blocking must allow for ventilation, access, and flood openings. Where sheathing is installed on the inside face, see A304.4.3 requirements for stud bay ventilation. See A304.4.4 requirements for underfloor ventilation. See A304.4.4 requirements for flood vents. Maintain required access openings. This photo points out vents into the dwelling's crawl space. Step 11. Building department minimum required inspections are listed as 1. Placement and installation of adhesive and expansion anchors. 2. Installation and nailing of cripple wall bracing. 3. Work may be specified by the building department, such as requiring special inspection. Steps 1 through 11 address the primary steps identified by CEBC Appendix Chapter A3. The ICC commentary to IEBC provides detailed explanations of Appendix Chapter A3 requirements, along with many applicable recommendations and cautions. This figure shows ways to indicate anchor bolt locations and length of new sheathing, right-hand side, and details for wall top, connection to rim joist or blocking, wall sheathing, and detail for wall bottom, anchor bolts, etc. Note that examples are shown in limited locations, not throughout the structure. IEBC Appendix Chapter A3 has been presented here because it is a national model code. Other resources have been developed by local communities. Some of those resources include Seattle Project Impact Home Earthquake Retrofit Series 1. Overview, 2. How to complete the home assessment checklist, 3. Guide to completing an earthquake retrofit plan for wood-framed residential buildings, City of Los Angeles Earthquake Hazard Reduction in Existing Wood-Frame Residential Buildings with Weak Cripple Wall and Unbolted Sill Plates, Standard Plan Number 1, City of San Leandro Residential Retrofit Handbook Residential Retrofit Plan Set, Committee of East Bay and Peninsula Chapters of ICC Plan Set A, Residential Seismic Strengthening Plan, available on the ABAG website, abag.org. You have completed Part 5 of the educational module. Contractors, please return to the contractor dashboard to take a short quiz.